For the next thing we're going to do, it's going to be useful to have access to a list of certain nice numbers. A list of perfect squares, that is the result of taking an integer to the second power, and a list of perfect cubes, that is the result of taking an integer to the third power. As we spend a lot of time factoring, we're going to find that we memorize some of these lists, but if you don't have a list like this memorized, you can write out a list like this, or you can use a computer or a calculator to make one. We're going to see a way to get a list like this on the TI-84 and use that to identify some numbers as perfect squares or cubes. Of course, the TI-84 is not magic. If you have a different kind of calculator, check in with me and see if it's capable of making a list like this. In order to make a list of perfect squares, we'll hit y equals on the TI-84 and enter x squared as y1. To get a list of perfect cubes, we'll enter x cubed as y2. We can continue on and get higher powers of x if we want. And then we'll hit second graph to access the table feature. Let's see how that works. I'm going to y equals. I'm going to enter x, exponent key 2 to enter x squared. I'm going to hit x, exponent key 3 to enter x cubed. And then I'm going to hit second, and then the table button to get a table. And from here, I'm going to look at the numbers that I want to consider, because I may need to scroll through this list. So 20, I notice that 20 is between 16 and 25. So it's not a perfect square. I notice that 20 is between 8 and 27. So it's not a perfect cube. It must be that it's neither of those. 49, I see that 49 is in fact a perfect square. Right? 49 is 7 squared. However, I see that it's between 27 and 64, so it's not a perfect cube. I see that 125 is a perfect cube, right? It's 5 cubed, so it is a perfect cube. On the other hand, well, it's more than 100, so it's not appearing on my list of perfect squares. I can scroll down a bit, and now I see that 125 is between 121 and 144. So it's not a perfect square. I need to check though, because a number can absolutely be both, right? Looking at my list, 64 is a perfect square. It's 8 squared. But it's also a perfect cube. It's 4 cubed. A number can be both a perfect square and a perfect cube. So just because I found it on one list doesn't mean I don't need to look for it on the other. Okay, how about 400? Right, 400 is between 243 and 512. So it's not a perfect cube. To see if it's a perfect square, well, it's more than 144. So I need to keep scrolling down. Oh, yeah, there it is. 400 is 20 squared. It is a perfect square. And finally, what about 200? Well, 200 is between 196 and 225. So it's not a perfect square. For the perfect cubes, it looks like I need to scroll back up. Oh, 200 is between 125 and 216. So it's not a perfect cube. It wasn't a perfect square, it wasn't a perfect cube, it's neither one. So that's how we use a table like this to identify whether or not numbers are perfect squares, whether or not they're perfect cubes.